We are asked to use the quadratic formula for this style of problem. They want us to solve for the roots in its simplest form, and we have to use the quadratic formula. And here is our quadratic equation. It's quadratic because of the highest degree, or the degree here is 2. The biggest exponent is 2. To use the quadratic formula, it's basically like the zero product property. We need to move everything over to the side so it equals 0. So I'll have 4x squared plus 13. Don't do your math on your original problem. That's bad form. And we will move everything over to the left side so we can keep a positive. Quadratic formula doesn't matter, but it's nice, makes it a little bit easier. So I'll add 20x to both sides plus 20x. That gives us 4x squared. Put everything in order, in descending order, 20x plus 13. All of that equals 0. Now we can use the quadratic formula. I like using a foundation underneath it so I can match it. The foundation equation for x squared is ax squared plus bx plus c equals 0 for this case. And then now it's clear what we can see each of the letters are going to be, what A, B, and C are, what the parameters are here. So I like doing it this way because it makes it very clean and easy, and we're reinforcing what the equation is here. So now we're going to go ahead and use the quadratic formula. Do you remember the quadratic formula? It's important. You should have this in your math tool belt. The quadratic formula is when you're solving for x. This gives us our solutions, our roots, or our x-intercepts. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure your square root goes over everything that should be under it or inside of it, like that. Okay, so now I'm just going to go ahead and plug everything into this formula. It's really important that you write your formula. It's kind of like you're giving credit to the math originators that are using this formula. We don't want to plagiarize it. Also, you're less likely to make mistakes if you have the formula right out in front of you and you're plugging things in. So I'm going to plug in everything I see. Negative b is 20, plus or minus the square root of b squared is 20 squared. If that were a negative, I would need parentheses there, but it's not, so we're okay. Minus 4. A is 4. That does need to be in parentheses. C is 13. Okay. All divided by 2 times A. A is 4 again. All right. We're simplifying. We could simplify in stages here. This 20, there's nothing that can be done there. The 2 times 4 is on the bottom or denominator. That's separated, so we could simplify that. The 20 squared is separate from the 4 times 13 because they're different terms. They're separated by that minus sign. So x equals negative 20 plus or minus the square root. 20 squared is 400. Double the 0, and 2 times 2 is 4. Minus 4 times 4 is 16 times 13 is 16 times 13 is 208. All right. And we all have an 8 on the bottom for this one. Okay. So now I'll go ahead and combine right here what's under the radical, negative 20 plus or minus. The square root of 400 minus 208 is 192. All over 8. Now 192 is an even number, so it looks like that rational number simplifies. Radical. This radical simplifies. So we need to simplify this square root. So to do that, I use a little trick. I use its prime factorization, and anytime I have a pair of numbers under here, I can pull it out. So this is my side work. I'm trying to simplify the 192 under the square root sign. So I'm doing a prime factorization. That's 2 times 96. That's 2 times 48. That's 2 times 24. 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. All right, so for my side work here, the square root of 192, oh, that turned out ugly. The square root of 192 is equal to all of these prime factors underneath it. So that's how many 2's? 1, 2, 3, 4, 5, 6 times 3. 1, 2, 3, 4, 5, 6 times 3. And each of these are being multiplied together. Now my trick is when you have a pair of these, you can pull out 1. So I have a pair of 2's. That'll come out as 1, 2. I have another pair of 2's. That comes out as 1, 2. I have another pair of 2's. That comes out as 1, 2. All right. And then I have my 3 left over under the radical. So what this turns into is 2 times 2 times 2 radical 3, which is 8 radical 3. Okay, so that looks like almost everything we need. Let me go ahead and erase a little bit. So let me get this out of the way. Okay. Almost done. All right. So I have my original right here. The x equals negative 20 plus or minus square root of 198 over 8. So I can now rewrite that as x equals negative 20 plus or minus. Instead of square root of 192, I do the square root. I do 8. Square root of 3. And that's what I found right here. 8 square root of 3 is the same thing as square root of 192. All of that is over 8. All right. Getting close to the end now. So now I need to simplify this a little bit more. Each of these the 8 goes into each of these terms right here. So that's equal to negative 20 divided by 8, plus or minus. And I won't skip any steps here. 8 radical 3 over 8. All right, let's just reduce our fractions. 8 goes into 20. Let's see, 4 goes into each of those. So 4 goes into 20 5 times. 4 goes into 8 twice. Still have our plus and minus. And 8 and 8 reduce out. I still have the radical 3. This looks like everything we need here. And notice that this answer right here, we have the option of the plus or minus sign. So let's see how we did. Our answer should be negative 5 divided by 2. Get out of the denominator, plus or minus sign, radical, and 3. Got it.